Today we're looking at geometric sequence and series. We're gonna look at the derivation of the finite sequence and series. Okay, so I'll give an example here first. What is a sequence? Sequence is a list of numbers here that you see here, an array of numbers, and geometric has a common ratio. For example, if we multiply this by a number, which is 2, we're going to multiply by 2 to get the next number. This common ratio has a common ratio of 2, or how we can say it is this number divided by the preceding number is equal to 2. 16 divided by 8, 2. 32 divided by 16, 2, and so forth here. So if the common ratio is 2 for every single term here, it's called a geometric sequence. Now when we add those terms, it's called the geometric series. So if we're adding all the terms in the sequence, it's called a series. So we're going to derive the finite sum of the geometric sequences. So we're going to, when we add it up, it's going to be a series. Okay, so let's start off with looking at this. For example, here we're going to label this as first the a. So what did we do to a here? We multiplied it by a common ratio, which is r. What we did again, we multiplied it by another r, gives you r squared, and so forth. Okay. So next, when we said this is the sequence, okay, so we're gonna derive the finite sum. Okay, this is the sequence, and then what we do is we're gonna take the sum of the first n terms. So we're listing it as s sub n. A plus 8r plus ar squared plus ar cubed plus, and I'm gonna put dot 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 ellipses here plus a to the r to the n minus 1. Okay, next we're gonna do, to derive it, I'm gonna multiply both sides by r times s to the n. So this is gonna be a to the r multiplied by r plus a to the r squared plus a to the r cubed plus a to the r fourth plus dot 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 plus a to the r n minus 1. And when you multiply this here, we're going to multiply by r, you're going to have this one here. When you multiply this by r, you're going to have a to the r to the n. Okay, so I just placed this in here because it'll become relevant when we do our calculations. Okay. So now we have the two equations we need. So what we need to do now is we need to take this first one and subtract it from to the second one. So s of n minus r s of n. So the left side, s of n minus r s of n equals, so I'm gonna do this part here. Okay, so I'm gonna go a plus ar plus ar squared plus ar cubed plus dot 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 plus 8r to the n minus 1 minus, and I'm gonna write this here just for completeness, dot dot dot, I didn't write this in, but it's in there, ar n minus 1 plus a to the r to the n. Okay, now what you see here is that you factor out everything here. What you're gonna see here, notice a to the r cancels with this one, this gonna cancel, ar cubed minus, there's a minus here, So everything you see here will cancel. What you're left with is a minus a to the rn. This one and that one. Okay? So from here, remember we defined our definition, the sum of the first n terms, 1, 2, 3, 4, 5, all the way to, this is the nth term right here. Okay? So what we're gonna do now is factor out s of n, 1 minus r equals a. I'm gonna factor out the a, 1 minus r to the n. Okay. From here, I'm gonna divide by 1 minus r. So what we have is a 1 minus r to the n over 1 minus r. Okay, so this is the, and of course formulas are good for verifying, so we got to verify, and we're going to verify that. So let's take something really simple here. I'm gonna use this one actually here. So 4 plus 8 plus 16 plus 32 plus 64 plus 128. So we have 1, 2, 3, 4, 5, 6. So what is S sub n here? S sub n is 4 is your first term, 1 minus, and remember what I said, the common ratio here was 2. 1 minus 2 raised to the 1, 2, 3, 4, 5, 6. Okay. All over 1 minus 2. So when you get your calculator, this is 64. 1 minus 64 is 63. Negative 63 over negative 1. 4 times negative 63 divided by negative 1 is equal to 252. So but when you get your calculator here, and I'm just gonna direct addition here, add across, plus 16 plus 32 plus 64 plus 128, and it gives you 252. And you can verify that this is the derivation. Okay, in the next video we'll have the infinite geometric sequence and infinite geometric series.